Hi, today we're going to be practicing solving word problems using equations. We just start off by reminding you about the process that we need to follow when we are using equations to solve word problems. First, you need to express your unknown values in terms of x. So you need to read the problem carefully and determine what you're being asked to work out. Make the unknown value x and write it down normally as let whatever it is be x. Then, if the word problem contains more than one unknown value, you usually make the one that you need to work out x. There are exceptions though. One exception is when one value is a fraction of the other or a multiple of the other. You can sometimes avoid working with fractions by making the smaller value x. You can't always avoid it, but you often can. Then you also need to write any other unknown values in terms of x as well. For example, things like x plus 2 or 2x, however the other value is related to whatever you made x. Once you've expressed your unknown values in terms of x, the next thing you need to do is set up an equation and then solve it. Okay, so you need to use the information that you've been given in the word problem to make an equation that you can use to solve for x. And then once you've got your equation, you then need to go and solve it and work out what x is. Then, once you've got your value of x, you need to go and answer the question that you asked. You need to go back and look at the question again, and you need to give your answer in terms of the question that was asked. So don't just give your answer as a number or leave your answer as x equals whatever the value was. You need to put it back into the context of the question again. Okay, so let's have a look at an example. In this example, a father is 30 years older than his son. 5 years from now, he will be twice as old as his son. How old are they now? Let's take a look and see how we would solve this problem. Okay, so the first thing I need to do is I need to identify my unknown values and express them in terms of x. So the unknown values are the father's age and the son's age. We need to know how old they are now. So I'm going to make the son's age x Okay, now because the son's age is x, I'm going to say the father's age in terms of x. So we were told that the father is 30 years older than the son. So to work out how old the father is, we take the son's age and we add 30. So therefore the father's age is going to be x plus 30. So this over here is now. That's how old they are now. Now we also need to look at the other information they gave us. They told us that in 5 years, the father will be twice as old as the son. Okay, so let's just see, normally, how would you work out how old you're going to be in 5 years' time? You take your age now and you add 5. So I'm going to take each of their ages, and I'm going to work out what it'll be in 5 years' time in terms of x, and then I'm going to use the other information that I haven't used yet, which is that stuff about it being twice as old in 5 years' time. That I'm going to use to set up my equation, okay? But I know that I need to have information about their ages in 5 years' time. So let's use what we've got over here and convert that to what it will be in 5 years' time. So in 5 years' time, the son's age will be x plus 5. You always add 5 to work out how old somebody's going to be in 5 years' time. So we take his age now and we add 5. And then we do the same thing with the father's age. We're going to take his age now, which is x plus 30, and we're going to add 5 to that. Okay, so now I've got what the ages are now, and I've got what the ages will be in 5 years' time, all written in terms of x. Now this could also have been written in the form of a table. So it's up to you if you want to do it in the form of a table to make it easier to maybe see what's going on. You can do that. So your table will look something like this. So we've got the son's age and the father's age. Then I've got now and in 5 years' time. Okay, so over here, the son's age now, I made x, and the father's age now is x plus 30 because he's 30 years older than the son. And then in 5 years' time, I just add 5 to both of their ages. So x plus 5 and x plus 30 also plus 5. Okay, so that is another way of writing the same information that just maybe makes it a little bit easier to see what is going on. Okay, you can choose how you want to express it. Obviously you don't have to do both. I'm just showing you both options. Okay, right, so now that I've got my first step done, which is identifying and expressing the unknown values in terms of x, now I need to go and set up my equation. So I'm going to go and look for the information that I haven't used from the question yet. So they told us the father is 30 years older than the son. We've used that. Over here, we said the son is x and the father is x plus 30 because he's 30 years older. Then they said 5 years from now, so now in 5 years, we added 5 to each of their ages to find out what their age would be in 5 years. But now we haven't used this information yet, where it said 5 years from now, he will be twice as old as his son. We haven't used that information yet. That is what we're going to use now to write out our equation. So now we need to see what is his age going to be in 5 years' time. His age in 5 years' time, the father's age, is x plus 30 plus 5, or x plus 35. You can simplify that as well. So I've got the father's age is x plus 30 plus 5, and we're told that in 5 years' time, that's what his age is in 5 years' time, his age will be the same as twice his son's age. So his son's age in 5 years' time is x plus 5. And if I double that, so I times it by 2, and I have to put it in brackets because I'm multiplying the whole age by 2. So if I double that, I will find out what the father's age is in 5 years' time. So that's how I use that information they gave me that I didn't use yet to set up my equation. The father's age in 5 years' time is double or twice the son's age in 5 years' time. Okay, now we're going to go and solve for x. So now I'm going to multiply this out. So this is going to be x plus, I'm going to simplify that, that's 35 equals 2 times x is 2x, and 2 times 5 is plus 10. So now I'm going to get rid of the 2x over here by subtracting on both sides. So I've got x minus 2x is negative x equals, and then I subtract the 35 on both sides. So I have 10 minus 35 gives me negative 25. Sorry about that. And then I'm going to go and divide by negative 1 on both sides to get just x. So therefore, x is equal to positive 25. Okay, so now I've solved my equation and I've worked out what x is. Okay, now the next thing I need to do is I need to go and answer the question. So the question was, how old are they now? Okay, just leaving my answer like this, x equals 25. If somebody just looks at that, they're not going to know what x is supposed to be. You have to put it back into the context of the question. So the question is, how old are they now? So x, we said, was the son's age. So now we can say, therefore, the son is 25 years old, and the father is, now the father was x plus 30. So it's 25 plus 30, which gives us 55 years old. And that's how you would solve that question. Okay, now I'm going to give you a few that you're going to do for yourself. Here's the first one. 5 more than twice a number is equal to 19. Find the number. I'm going to give you 1 minute to solve this problem. Okay, so let's go through that question. So the first thing you have to do is express your unknown in terms of x. So over here, we've been told 5 more than twice the number is equal to 19, and we need to find the number. There's only one unknown value in this question, and that is the number. So we're going to say let the number be x. Okay, so we've made the unknown, which is the number, x. Now we're going to go and set up our equation. So they've told us 5 more than twice a number. Okay, so twice a number means we're doubling the number. We're timesing it by 2. And 5 more than that means we're adding 5 to that. So it's going to be 2x to get twice the number plus 5. And then they say it's equal to 19. So equals 19. So that's our equation. 2x plus 5 equals 19. Now I'm going to go and solve for x. So I have 2x equals 19 minus 5, which is 14. And then I'm going to divide by 2. So therefore, x is equal to 7. Okay, so now I've worked out what x is. So I need to go and answer the question. The question was find the number. So now I'm going to go and say, therefore, the number is 7. Okay, so that you should have got for question A. Let's go on to question B. Question B says, a runner completes a race by running, jogging, and walking a total of 17 kilometers. She jogged twice as far as she ran and walked 3 kilometers less than she jogged. How far did she walk? Okay, I'm going to give you 2 minutes to solve this problem. Okay, so let's go through that question. So first of all, I need to write my unknown values in terms of x. This particular question has got 3 unknown values: the distance that she walked, the distance that she jogged, and the distance that she ran. We've been asked to work out the distance that she walked. And now I said to you in the beginning that normally we try and make the value that we're being asked to work out x. But in this particular question, I'm not going to do that, because if I try and make the distance that she walked x, the other 2 values are going to be very complicated in terms of x. The easiest one to make x is actually the distance that she ran. Because if I look at the relationship between the distance that she ran and the distance that she jogged, we were told that she jogged twice as far as she ran. Now remember, I told you in the beginning, when you've got one value that is a multiple of the other, it's better to make the smaller one x. So here, the distance that she jogged is twice as far as the distance that she ran. So the distance she ran is the smaller value. So I'm going to make that one x. So the distance that she ran is going to be x. So I'm making the distance run x. Therefore, the distance jogged is going to be twice that, because they told us she jogged twice as far as she ran. So I'm going to double the x, so that's going to be 2x, and then I can go and do the distance that she walked, because they told us that the distance she walked was 3 kilometers less than the distance she jogged. So now that I've got the distance that she jogged in terms of x, I can use that to write down the distance that she walked in terms of x. So the distance walked is going to be the distance jogged, which is 2x, minus 3, because she walked 3 kilometers less than she jogged. So those are our 3 unknown values now written in terms of x. I made the distance that she ran x because that was the one where I had 2 that were, one was a multiple of the other one, and that is the one that was smaller. So that's why I made the distance that she ran x. And then I was able to use that to help me to work out the other ones in terms of x. Okay, now we need to go and set up our equation. So they told us that the total distance that she ran, jogged, and walked is 17. So all I need to do is take these 3 values and add them to get the total. So it's x, the distance that she ran, plus 2x, which is the distance that she jogged, plus 2x minus 3, which is the distance that she walked. And all of that together is 17 kilometers. It's the total distance that she ran, jogged, and walked. Okay, now we can go and solve for x. So I've got x plus 2x, that's 5x, equals 17 plus 3 is 20. So then this is going to be x equals 20 divided by 5, which is 4. So now I know that x is 4. Okay, so now I need to go and answer the question. The question is, how far did she walk? So now we need to go and see the distance walked is 2x minus 3. So we just worked out what x is. Okay, so she didn't walk 4 kilometers. 4 is not our final answer. We need to work out the distance that she walked using the 4. So the distance that she walked is going to be 2 times 4 minus 3, because it's 2x minus 3. So that gives us 8 minus 3, which is 5. So therefore, she walked 5 kilometers. And that's what you should have got for question B. Okay, now let's go on to the next one. For question C, you've been told that the length of a rectangle is 6 centimeters more than the width. If the perimeter is 40 centimeters, find the length and the width. I'm going to give you 2 minutes to work this one out as well. Okay, so let's go through that question. Right, so this question has got two unknown values. The length and the width are both unknowns, and we need to work out what both of them are. We need to make one of them x and the other one in terms of x. So they've told us the length of the rectangle is 6 centimeters more than the width. So they've told us what the length is in relation to the width. So I'm going to make the width x and then the length in terms of x. Okay, so let the width be x, therefore the length is x. They said the length is 6 more than the width, so I'm going to add 6 to the width to get the length. So it's x plus 6. Okay, so let me just quickly draw a very simple diagram to show you what this rectangle would look like. So I've got a rectangle where the width is x and the length is x plus 6. Now remember, when you're working out perimeter, because now they say that the perimeter is 40 centimeters, when you're working out the perimeter, you add up all the sides of your rectangle. So you can either just add them up, or you can use the formula for working out the perimeter of a rectangle, which is perimeter is 2 lengths plus 2 breadths. It doesn't matter which way around you do it, so long as you end up adding up all the sides. So over here, if this is x in a rectangle, the opposite side is the same, so it's also x. If this is x plus 6, then this is also going to be x plus 6. So I'm just going to go and add them all up, but if you use the perimeter formula, then that's absolutely fine as well. So I'm going to say the perimeter is the sum of all the sides. So I've got x plus 6 plus x plus x plus 6. And that is all equal to my perimeter, which they told us is 40 centimeters. Now we can go and solve for x. So I've got 1, 2, 3, 4 x's over here, so that's going to be 4x equals, I've got 6 and 6, that's 12. I'm going to subtract the 12 from the 40, and that gives me 28. So now I know that 4x is equal to 28, so therefore x is going to be equal to 7. Okay, now we have to go and answer the question. So we've worked out what x is. Now we're going to go and put it back into the context of the question and answer the question. The question was, find the length and the width. Okay, so now I know the width is x and the length is x plus 6. So I'm going to use the x value I got over here to answer and find out what the length and the width are. So therefore, the width is going to be x, which is 7. And that is 7 centimeters. And the length is x plus 6. So it's going to be 7 plus 6, which is 13 centimeters. So that's what you should have got for question C. Right, let's go on to question D. In question D, you've been told, in a game, players earn 4 points for a win and lose 3 points for a loss. If a player completes 25 games and scores 30 points, how many games did they win? I'm going to give you 2 minutes to solve this one as well. Okay, so let's go through that question. So in this one, we have got two unknowns, the number of games that were lost and the number of games that were won. We need to work out how many they won. So I'm going to make the number of games that they won x. Okay, so let the number of wins be x, and that means that the number of losses, the number of games that they lost, is all the rest of the games. So they told us that the player completes 25 games. The number of games that they won and the number of games that they lost have to add up to 25. So if I have made the number of games that they won x, then the number of games that they lost is going to be the total, which is 25, minus the games that they won. So it's going to be 25 minus x. Okay, so that's what you should have started with, that the number of games that they won was x, and the number of games that they lost was 25 minus x. Now we have to go and set up our equation using the other information that we haven't used yet. So they told us that the player earns 4 points when they win a game, and they lose 3 points when they lose a game, and that they won, or they scored 30 points altogether. Okay, so first of all, for every game that they win, they gain 4 points. Okay, so it's going to be a positive amount of points that they're going to get. They're adding to the points that they have. So we're going to have 4, the number of points that they get, multiplied by the number of games that they win, which is x. Okay, so 4x, that's going to help me to work out how many points they got altogether from all the games that they won. But then, when they lose a game, they lose points. So that means we have to take points away again. So for every time that they lose a game, we're going to be subtracting 3 points. So I'm going to have minus 3, and that must be multiplied by the number of games that they lost, which is 25 minus x. That must go in brackets because I have to multiply the whole thing by that negative 3. So I've got 4x minus 3 times 25 minus x, and that is equal to the total number of points that they ended up with, okay, which is 30 points. Now we can go and solve for x. So I've got 4x, then negative 3 times 25 is minus 75, negative 3 times negative x is plus 3x equals 30. So now I'm going to have 4x plus 3x is 7x on the left, and then 30, and then I'm going to add 75 on both sides. So I have 30 plus 75, that gives me 105. Okay, so now I know that 7x is 105, so I need to divide by 7 to get what x is. So 105 divided by 7 is 15. So now I know that x is 15. So now I need to go back and answer the question again. We've solved for x. Now I need to go and answer the question. The question was, how many games did they win? So let's go back. We have the number of wins was x. So the 15 over here is the answer to my question. So therefore, they won 15 games. And that's what you should have got for question D. Right, let's go on to question E. So question E says, Amanda cycles at 10 kilometers per hour and walks at 5 kilometers per hour. If she cycles to school, she arrives 18 minutes earlier than if she walks. Find the distance to her school. I just want to remind you before you do this question about our triangle that we can use to help us when we're working with speed, distance, and time problems. You are going to be using the relationship between speed, distance, and time in this question. So I recommend that you use that triangle to help you. Okay, so I'm going to give you 3 minutes to solve this problem. Okay, so let's go through this question. So first of all, they've told us two different speeds. They've given us the speed at which Amanda cycles, which is 10 kilometers per hour, and the speed at which she walks, which is 5 kilometers per hour. They've also told us the comparison, or they've given us the difference between the length of time it takes her to get to school if she cycles compared to if she walks. They've told us that she will arrive 18 minutes earlier if she cycles than she will if she walks. And we need to work out the distance to her school. Okay, so this is another example where I'm actually going to be putting our values, everything in terms of x, in the form of a table because it's going to be easier to see what's going on. So let me show you over here. So over here, I've got my table. I'm going to have in my table speed, distance, and time. And then the two different ways that she travels, which is cycling and walking. So when she cycles, her speed, they told us, is 10 kilometers per hour. And when she walks, her speed is 5 kilometers per hour. Okay, that they told us, it's given. Then the distance is what we need to work out. So I'm going to make that x. And whether she's cycling or walking, the distance is the same. So for both of them, the distance is going to be x. Okay, now we need to have our time, which we're going to be expressing in terms of x. Now they've given us some information about the time. They've told us the difference between the times if she cycles and if she walks is 18 minutes. I'm not going to use that yet though. That's going to help me to set up my equation. What I'm going to do over here is use my speed, distance, and time relationship to help me to work out what the time is in terms of x. So remember our relationship over here, I've got speed is distance over time. So my time, I can look at it from this side over here, time is distance over speed. So the distance is x, so the time will be x over the speed, which is 10. X over 10. And for if she's walking, I do the exact same thing. The time is going to be the distance, which is x, over the speed, which is 5. So x over 5. Okay, so now I've got her time in terms of x. They've given me the relationship between the two different times. They've told me the difference between them. So now I can use these over here with the 18 minutes that they gave me to help me to solve for x. The problem I have now though is that 18 minutes is not the correct unit of measurement because this is in kilometers per hour. So this time over here is going to be hours. This distance is kilometers. It's x kilometers and the time is x over 10 hours and x over 5 hours. Okay, so now I need to go and convert my 18 minutes into hours. And how do we convert from minutes to hours? We divide by 60. So 18 minutes is the same as 18 over 60 hours. Now I'm going to keep it as a fraction like that because I've got fractions here anyway. So I'm going to be putting it all together as fractions in my equation, and then I'll eliminate the denominators like we've learned how to do when we're doing equations with fractions. Okay, so now I've got x over 10, x over 5 as my two times for when she's cycling and walking, and 18 over 60 as the difference between the two times. Okay, so now what you need to be aware of is if she is cycling, she's going to get there quicker, so the amount of time is less. So this one over here is less time. And this one over here, when she's walking, because she's going slower, is going to take her longer. So the amount of time is more. So this is more time. I just want you to be aware of that because it can be confusing about which way around I'm going to be working with my times over here. Okay, so now remember that 18 minutes is the difference between the times, okay? She would arrive 18 minutes earlier if she is going to cycle than if she's going to walk. So the 18 minutes is the difference between the two times. Now remember, difference means subtraction. So I'm going to take these two times and I'm going to subtract them to get the difference, which is the 18 minutes or 18 over 60. But remember, we have to take the bigger amount minus the smaller amount. That's why you need to know which one over here is bigger and which one is smaller. The x over 5, which is the time that she takes to walk, is the longer time. It's the bigger amount. It's the bigger time. So it's going to be x over 5 minus x over 10. And that gives me the difference between the two times, which is 18 over 60 for the 18 minutes. Okay, so now I've got my equation. The time that she takes to walk minus the time that she takes to cycle gives me 18 minutes, because the walking is 18 minutes more than the cycling. Okay, so now we can go and solve for x. I've got denominators here. I need to find my LCD. So the LCD for 5, 10, and 60 is going to be 60. So I need to multiply 5 by 12 to get 60. So I'm going to multiply x by 12. That gives me 12x minus 12x minus. Then I need to multiply 10 by 6 to get 60. So I'm going to multiply the top by 6. That gives me minus 6x equals. And then over here, this is already 60, so I don't need to multiply by anything. So it stays 18. Okay, and now I can just solve for x. So I've got 12x minus 6x. That gives me 6x equals 18. Therefore, x is equal to 18 divided by 6, which is 3. Okay, so now I know that x is 3. So now I can go back and answer the question. The question was find the distance to her school. So if I look back at my table that I have over here, I had x for distance. So I have already worked out what the distance is. I just need to go and use it to answer the question. So therefore, the distance is 3, and that is 3 kilometers. So that's what you should have got for question E. Right, let's go on to the last one for today. In question F, you're told that the area of a rectangle is 48 centimeters. If the breadth is tripled and the length is left unchanged, it becomes a square. Find the dimensions of the rectangle. For this one, you're going to need to use the area formula. So please try and remember what that area formula is. The area of a rectangle is length times breadth. Okay, so I'm going to give you 3 minutes to solve this problem. Okay, let's go through that question. So for this question, we've been told that the area of a rectangle is 48 centimeters. If the breadth is tripled and the length is left unchanged, then it will become a square. We need to find out what the dimensions of the rectangle are. So first of all, we need to know what that means. The dimensions are the length and the breadth of the rectangle. So we've been asked to work out what the length is and what the breadth is. So we need to make one of them x and the other one in terms of x. Okay, so now I'm going to make the breadth x because I've been told that it is going to be tripled. So that means I'm going to have to multiply it by 3. Now it's going to be easier to multiply x by 3 than something else that's in terms of x and multiplying that by 3. So I need to make the breadth x. Okay, so let the breadth be x. Okay, then I need to go and say what the length is going to be in terms of x. Therefore, the length is, okay, now to work out what the length is, we have to use the formula for the area of a rectangle. Now remember, the formula is area equals length times breadth. This is very similar to what we have with our speed, distance, time triangle. We can do the same thing with our area formula over here, that the length and breadth, because they're being multiplied, they go at the bottom. So length and breadth go at the bottom and the area goes at the top. So the length is the same as the area divided by the breadth. So I've got the area, it's 48. And I need to divide that by the breadth, which is x, to get the length. So it's 48 divided by x. Okay, and that makes sense. If you've got the area of a rectangle, you can divide the area by one side to find out what the other side is. Okay, so that's all I'm doing over here. So I'm taking the area and I'm dividing it by the breadth to get the length. Okay, so now I've got both of those in terms of x. Now we're going to go and use the other information they've told us in the problem that we haven't used yet. So they told us that if the breadth is tripled, it will become a square. Okay, so if I have my rectangle like this, okay, where my breadth is x and my length is 48 over x, then they tell us that the breadth is tripled. Okay, so that means I'm going to have one x, I'm going to have another x, and another x. Okay, and that will make this turn into a square. So over here, I've got another x up to there and another x over here. So this whole thing, because it's been tripled, is now 3x. Okay, and because it's a square, you have to use what you know about a square. And what we know about a square is that the length and the breadth are equal to each other. So this 3x is going to be the same as the 48 over x. And that's what we're going to be using now to make our equation. That 3x, once it's been tripled, once the breadth has been tripled, the 3x is equal to the 48 over x, which is the length, because it's now a square. So they're equal to each other. So that's 48 over x. Okay, so now we've got an equation with a fraction. So my LCD is going to be, the denominator over here is x. This one has a denominator of 1. You can't see it, but it is there. So we're going to multiply 1 by x. So I've got at the top here 3x times x as well. So it'll be 3x squared equals, and then this one's already x, so I don't need to multiply by anything, so it stays as it is. So it's just going to stay 48. Okay, so now I've got 3x squared equals 48. Okay, so now I need to get the x squared on its own by dividing both sides by 3. So I've got x squared equals 48 divided by 3 is 16. And now we've got an equation with an exponent. Okay, now we've learned how to do this. When you have x squared equals something, because it's an even exponent, we have to remember that this could be positive or negative. When I change it into a power, the base could be positive or negative. So I can say x squared is equal to, I need to get a power with the same exponent on this side over here. So 16 is the same as 4 squared. So it's going to be 4 squared. But remember, I could square positive or negative 4. So it's going to be plus or minus 4 squared. Okay, now because I have the same exponents, I can drop them. So I can say, therefore, x is equal to positive or negative 4. Okay, but now let's think about this logically. X is the breadth of a rectangle. It cannot possibly be a negative value. You can't have a negative side of a rectangle. It's not going to work. Okay, so now we can eliminate the negative 4 as a possible solution because it's not realistic. Okay, So we can say x cannot be equal to -4, and my reason for that is because it's the breadth of a rectangle. You can't have a negative length of a rectangle or a negative side of a rectangle. Okay, so x can't be -4. So therefore, I can now give my solution, and I can say that the answer to the question they asked, which was to find the dimensions of the rectangle, I need to find the length and the breadth. I'm going to be using the +4 value. So therefore, I can say x is equal to +4. So now, x is my breadth. So my answer for my question is that the breadth is 4 centimeters, and the length is, remember we had over here that the length is 48 over x, so it's 48 divided by 4, which is 12 centimeters. So that's what you should have got for question F. And that is how we used equations to solve word problems. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.